Hi children, in the concept of motion, at the end we are going to discuss IIT problems. Okay, see now. We'll discuss some IIT problems and short answer questions even. See now, define rest. So what is rest? Already we have discussed. An object is said to be at rest if it does not change its position with respect to time and observer. Okay, and for the rest there is no unit. And what is motion? An object is said to be in motion if it changes its position with time and observer, and there is no unit for both the things. Next, what define displacement? The shortest distance between the 2 points or initial and final position. Two positions are 2 points. The shortest distance we call it as displacement. Define velocity. The rate of change of displacement is called velocity. It is called as V is equals to or rate of change of ds by dt. So ds in the sense differentiation we are going to call, that is change in displacement by time taken. Okay, is called, the unit is displacement by time, the unit is meter per second. The unit of displacement is meter and the unit of time is second, meter per second. Define acceleration. What is acceleration? The rate of change of velocity is called acceleration. Change in velocity, we call it as acceleration. A is equal to dv by dt and the unit of velocity is meter per second by time, unit of time is second, so which is equal to, the unit is meter per second square. Likewise, we can define acceleration. Next thing is, how can one say that the tree on the earth is in state of rest and it is in state of motion at the same time? So, on the earth there is a tree. We should consider the tree is at rest position. In the same time, it should be considered in motion. How? See now. The tree is in rest position when considered with respect to the earth. Suppose if a person is standing beside the tree, with respect to on the earth, with respect to the observer, the tree is at rest. Similarly, the state of motion, how it can be considered? The tree is in state of motion when considered with respect to sun. If the observer is in the sky, okay, or is moving in an aeroplane whatsoever, so if you see with the telescope, okay, the tree seems to be in motion. Okay, tree seems to be in, the position of the observer has just changed. Okay, next one, give one example, give any one of the example in which a body travels with retardation or deacceleration. I mean, what is deacceleration? Decreasing of acceleration is called deacceleration. Increasing of velocity we call it as acceleration. Decreasing of velocity we call it as deacceleration. A car is moving and then applies brakes. The car travels with a decreasing speed. Finally, the body comes to rest. So, because retarding force is acting opposite to the direction of motion. So, the body, fast moving body, if it slows down, then that is called as retardation or deacceleration. A particle is moving in circular path of radius 7 centimeters. Find the ratio of displacement to the distance covered after completion of half circle. See here children, there is a circle here. Okay. What is the question? A particle is moving in circular path. What is the radius here? The radius of the circular path is 7 centimeters. Okay. And it is moving in circular path. Find the ratio of its displacement to the distance covered after completion of half circle. Suppose the particle is at the position A. In order to complete the half circle, the particle will be in the position B. The radius is 7 centimeters. So, This is total diameter. Total diameter is 7 plus 7, 14 centimeters. What is the displacement here? I need one more slide. See here children, what happens? A particle moving in circular path. So I will draw the figure here. This is some circular path and the radius is 7 centimeters and the total diameter will be 7 plus 7 centimeters. The body is at the position A and it has moved half the circle, that is up to the position B. So this one we call it as circumference of circle. Circumference of circle is, total circumference of circle is 2 pi r and it is half, it will be pi r. So distance will be AB, which is equals to pi r. What is radius? 7 centimeters. Pi is 22 by 7 into 7. 7 gets cancelled. It will be 22 centimeters. Then what about displacement? Displacement is nothing but the shortest distance, that is a straight line from A to B. So what is the distance here? 7 plus 7 centimeters, which is equal to, that is AB, which is equals to 7 plus 7, which is equals to 14 centimeters. Likewise, we can do the problem. See here, we shall read the problem. Find the minimum speed required by a person. Okay, find the minimum speed required by a person standing 5 meters behind a bus. The person is standing 5 meters behind a bus. To catch the bus in 1 minute. He should catch the bus in 1 minute. Okay, distance between person and bus is 5 meters, right? You have to write. And then what about the speed of the bus? Speed of the bus is 600 meter per minute. Speed is of bus is 600 meters per minute. 600 meters per minute, which is moving at a speed of. Convert this speed into meter per second also we have to convert. Right. Then what is the time given? Per minute means per 1 minute. So distance travelled by the bus in 1 minute. What is that? Distance travelled by the bus in 1 minute. So the distance travelled by the bus in 1 minute is, what is distance formula? Speed into time. Distance is equals to speed into time. So what is the speed of the bus here? 600 meters. Time is 1. So that is 600 meters. What is that value? 600 meters. After 1 minute, the bus is 600 meters ahead of starting point. Suppose this is the starting point. After 1 minute, the bus is 600 meters ahead. 600 meters ahead of starting point. So this is starting point of the bus. And a person is standing 5 meters behind the bus. There is a person here and he is 5 meters behind the bus. The person is standing 5 meters behind the bus. After 1 minute, the bus is 600 meters ahead. Okay, then what is the total distance the person should travel? Total distance the person should travel is 600 plus 5, which is equals to 605 meters. Okay, that is the total distance. Then what will be the minimum speed he has to cover? Speed is equals to distance by time taken, which is equals to, what is the total distance? That is 605 meters by 1 minute 1 minute can be written as 60 seconds. So the answer should be given in meter per second. 605 divided by 60 seconds, this is meters. So it is almost equal to 10 point something. Okay, it is 10.0 something, 10.08. Likewise you are going to get, that is meter per second. 60 ones are 60, tens are 60. So remaining 5, if you take put 0, 50 we are going to get. 6 8s are 48. So likewise we can solve the problem. Okay children. Second one, if a bus moves from A to B, where to where? A to B, and comes back to A, find the displacement and velocity. See, what is displacement? Change in position. Okay, displacement, shortest distance we call it as displacement. First initial position and final position. The initial position of the bus is here. Finally, it went to B and it come back here itself, that point A. So, what is displacement? 0. If displacement is 0, what about velocity? It is also 0. What is the speed of a body if it covers a distance of 20 meters in 4 seconds? Speed formula is distance by time. If it covers 20 meters in 4 seconds, that is 20 by 4, which is equals to 5 meter per second. 20 by 4. Distance is 20 meters and the speed is distance by 20 meters and time is 4 seconds. Now the problem is, find the acceleration of the car if it changes its velocity from 20 meters to 30 meters in 5 seconds. So if he has given two velocities, that is 20 to 30, we should consider the first one as initial velocity and the second one as final velocity. The initial velocity is represented by the letter U and the final velocity is represented by the letter V. So what is acceleration? A is equals to final velocity minus initial velocity by time taken, which is equals to final velocity is 30 and initial velocity is 20 by the time is 5 seconds. So which is equals to 10 by 5, that is 2 meter per second square. 2 meter per second square. So that is the acceleration. Then the next question is, write the differences between speed and velocity. Speed is defined as the rate of change of distance covered with respect to time, and velocity is defined as the rate of change of displacement covered with respect to time. Speed is the scalar quantity and the velocity is a vector quantity which is having both magnitude and direction. And the units of speed and velocity are same, that is meter per second. How do you represent a vector geometrically? Generally the vector is represented geometrically and it is directed by a ray. With the help of ray, the arrow indicates the direction of vector. So this is the direction of vector. We are going to represent a vector in form of a ray. Right? The next concept is, define distance, displacement and speed. Already we have covered in our classes. What is distance? The total path covered by an object is called distance. Example, a child runs along a curved path covering the total distance of 6 meters. The unit is meter. Then what is displacement? The shortest distance is called displacement. And next, what is speed? Speed is rate of change of displacement is called speed, that is displacement by time taken, which is meter per second unit. Okay, so next we go for one of the problem. When one of the passenger was traveling on the city bus, his mobile phone slipped from his hand and fall out of the window. This is fall out of the window onto the road. This was observed by a schoolboy standing near the road. The path of the mobile phone observed by the schoolboy is, generally the path will be a parabolic path. It will take this path, this type of path. So if it is fallen from the bus is moving in this particular direction, if it falls, so that if it is falling, it will take a parabolic path. Generally, we are going to learn in our future classes what is parabolic path. Generally, if you throw a stone up, so it will take a parabolic path, that is curved path. So likewise the mobile also, if it falls, so since the bus is in motion, it will take a parabolic path. Next one, convert 90 km per hour into meter per second. See here, 90 km per hour, 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 seconds. So if this is the situation, 90 into 1000, 2 zeros gets cancelled, 9 ones are 9 fours are 36, 100 by 4, which is equals to 100 by 4, which is equal to 25 meter per second. Likewise, we can calculate the speed, and we can convert the speed. Conversion of speed is very, very important, children. Right. Next thing, see here, this is one of the interesting problem here. When can we say that the particle is in motion, is moving with uniform speed? Yeah, so this is one of the question. A particle moving with uniform speed, we can say that the particle is in uniform speed if it covers equal distances in equal interval of time. There is one more problem. A boy is dropped from a height of 50 meters. So from 50 meters a boy is falling and he is dropped. Find the velocity of a body, not boy, a body. Find the velocity of the body at the end of every 5 seconds if the acceleration due to gravity is 10 meter per second square. So from 50 meters a body is falling. Every 5 seconds we have to calculate what? Acceleration. We have to calculate velocity of the body. So the formula is velocity, for the velocity the formula is v is equal to u plus at. So this equation is called equation of motion. In future classes you are going to learn this. Okay, anyhow you try to solve this problem. We try to solve this problem. See, initially the body will be at rest. So the initial velocity will be considered as u, that is 0. The acceleration is given in the problem, that is 10 meter per second square. V is equal to u plus at. The time is at 1 second. So that is 0 plus 10 into 1, that is 10 meter per second. So that is after 1 second the velocity. After 2 seconds the initial velocity will be 10 meter per second. So v is equal to u plus at. V is equals to 10 plus acceleration is 10 plus 1, that is 20. 10 into 1 is 20. 10 into 1 is 10. 10 plus 10 is 20. That is 20 meter per second. After 3 seconds the initial velocity becomes 20 meter per second. 20 plus acceleration is 10 into time is 1 second, that is 10 into 1 is 10, 20 plus 1 is 30 meter per second, and after 5 seconds velocity will be each second. After 4 seconds, not 5 seconds, it is 4 seconds. After 4 seconds velocity will be, initial velocity is 30 plus 10 into 1, that is 40 meter per second. Likewise we can calculate the problem. Next one, see here, a bus starts from rest and moves on a straight road. The distance covered by the bus in the given time interval is shown in the figure. So at time t is equal to 0, the bus is at the position A. After 1 second at B. After 2 seconds it is at 3. Identify the types of motion. Since the distance covered in increasing by the equal amount in every second, so the motion is uniformly accelerated. At first 2 next 2, next 2 like that. So therefore it is uniformly accelerated motion. It is 2 meter per second. First 1 second 2 meters, second 1 second plus 2, that is 4, and next 6. Calculate the change in velocity of every second. Velocity displacement by time taken in first second 2 meters, 2 by 1, which is equals to 2 meter per second, first one. And what about second? First to 2, it has covered 4 meters, 4 by 2, which is once again 2 meter per second. And in third one, the difference is 3 minus 2 is 1 second, and the distance is 2 meters again. 6 minus 4 is 2 meters, 2 by 1, which is equals to 2 meter per second square. So likewise we can calculate the acceleration of a body. So with this we have completed this lesson. Thank you. We will meet in the next class.